This video is about interpreting radian measure. In other words, can you explain what the numbers mean in trig functions and in inverse trig functions when it's not a special angle of pi or a fraction that's easy to recognize? Right here we have sine of 1, cosine of 1, and tangent of 1. 1 being 1 radian, because when we take the non-inverse function, sine, cosine, and tangent, the input is an angle. So you see here I drew a 1 radian angle. The radius is equal to the arc length in a 1 radian angle. So I'm going to label my angle as 1 radian. Now I want to know what these other three numbers mean, the 0.84, the 0.54, and the 1.557. What do they mean physically on this circle? So I'm going to drop down a perpendicular line to form a right angle. And if you recall, sine represents on a unit circle, so if this is a unit circle with radius 1, sine represents the y-coordinate and cosine represents the x-coordinate, or the opposite and the adjacent sides of this 1 radian angle. So I'm going to label this blue side here 0.84. That's the sine value. And I'll use a little red value here. This red value is the adjacent side. That is 0.54. Now thinking about the size of this unit circle, it has a radius of 1, so that's about halfway over to the radius. If you think about how this being a height of 1, the radius of 1, this is about 0.84 up, so that makes sense. Now what does the tangent mean? Most of you realize the tangent means y over x. If I divided 0.84 by 0.54, I would get 1.557. However, it also means slope. So what I'd like you to do is label the hypotenuse of the circle and say slope equals 1.557. So the slope of that line, that angle, is 1.557. Make sure you put the word slope in there, because otherwise I'll think you mean the length of that line is 1.557. Now let's look at another one. We have sine of 0.25. So if you think about this being 1 radian, half of that is about this big, and a fourth of that is maybe about down here. And so if I draw a fourth of a radian, it's about this big, maybe even a little smaller than that. Let me draw it slightly smaller. I'll do that in black. So that's a fourth of a radian, about there. So this is 1 radian angle. I can't really get the little arrow inside this, it's too small. Now I'm going to drop down a side here. The blue side is going to be my vertical side again. The vertical side is 0.247. Notice that why are 0.25 and sine of 0.25, why are those numbers so close in size? Well, if this is a unit circle and this cuts an arc of 0.25, whatever the radius is. So if this were 1 centimeter, this would be 0.25 centimeters. And notice that the vertical side and the length of the arc are almost exactly the same. That's why they're so close together. So this is 0.247. Now look at the size of the cosine value. The cosine value is nearly 1 because it's almost the whole length of this radius. It's 0.969. I'll just round it to that. And then our tangent value, this is tangent, got covered up there. The tangent value, or the slope of the angle, is 0.255. Once again, very close to the sine value and the actual measure of the angle, because if you're thinking about this is about 1/4 over 1, approximately. So those are some types of problems I'm going to ask you to do. I'll give you one of the three trig functions, and I'll give you either the inverse or the regular and ask you to draw a picture of what it means. So we'll do some practice on that at the bottom. Now just to recall, in order to do these problems, you really have to know this by heart. You need to know that sine of an angle is equal to a trig value. An example of that would be sine of pi over 3 is equal to the square root of 3 over 2. Pi over 3 is the angle, square root of 3 over 2 is the trig value. Inverse sine then of the trig value is equal to the angle. So when we do an inverse function, what happens is the angle and the trig value switch places. So an example of that would be inverse sine of the square root of 3 over 2 is equal to pi over 3. So these two values switched places. Now I don't want you to confuse that with the reciprocal function. The reciprocal of sine is cosecant. Now when we say cosecant, this is still an angle. We're taking cosecant of an angle. What changes is instead of the trig value, we're taking the reciprocal of the trig value of sine. So that's what switches. So when I do cosecant of pi over 3, what changes is that instead of square root of 3 over 2, it's 2 over the square root of 3. The trig value is flipped over. It's the reciprocal of the trig value. So you need to know all of these so that when you see numbers like we have below, notice I don't have any pi's or any fractions, so it's really hard to tell just by looking whether these are trig values or whether these are angles. Now I'm going to do these problems one at a time, and what you might want to do is see if you can draw it first and then pause it and then see if you get the same answer I get. So on all of these, what you're going to do is draw the angle. So you have to figure out which one of the two numbers is the angle. Show what physical, draw the reference triangle and show what physical quantity is represented by the trig value. For sine it will be the vertical leg, cosine the horizontal leg, and tangent it will be the slope. So let's just start out with the first one. Which of these numbers is the angle? Since it's sine and not inverse sine, the first number, the 5.7, is the angle, and the second number is the trig value. Now you might want to pause the video now and try drawing it and then turn back on and see what I drew. So I'm going to draw an angle of 5.7 radians. That's 5 and that's 6 approximately, so 5.7 would be about right here, and I'm going to label that as 5.7 radians. Then I'm going to drop a perpendicular line to the x-axis, and by the way, you always draw it to the x-axis because the angle that I'm trying to find is this little angle right in here. And since it's a sine value, it's going to represent the opposite side or the vertical side, and that is negative, so that makes sense, 0.5507, negative 0.5507, and it's about halfway down the radius, so it looks reasonable. Okay, pause now if you want to try number 2 without me, and then you can turn it back on in just a minute. Okay, this one is an inverse function now, which means that the 0.34 is the trig value, and the 1.2239 is the angle. So I may think of this differently. I know the adjacent side is 0.34. I know that the trig value 1.2 or the angle 1.2239 is somewhere up in here, but I'm kind of unsure of exactly where to draw it. I know it's somewhere between 1 and pi over 2, but so I'm going to think I know the adjacent side is about 0.34, which is about a third of the radius. So I'm going to draw my adjacent side first, bring a line straight up, and then this would have to be my angle. So that is a way to do it. You don't have to do it that way. You can just kind of guesstimate where 1.2239 is, but that's in my angle in radians. And then this side right here is 0.34 because it's the adjacent side. I'll draw that, write that a little better. 0.34. Okay, third one, once again, turn it off if you'd like. Do notice that there's a negative number here, and you have to kind of decide what to do with that negative number. Okay, if you're checking this again, this is the angle, negative angle, and this is the trig value. Now, I know that tangent is slope, and so this is a slope of about 1, and that reminds me, okay, anything that has a slope of about 1 or negative 1 is a 45-degree angle. This angle is negative, which means I have to go backwards. So where it's going to end up is in quadrant 3, and it's going to end at about a 45-degree angle because I know that the slope of this line has to be about 1. So here's my angle, negative 2.3561. The slope here is equal to 1.0002. Remember to write slope, the word slope, when you put that in. So these are some examples of problems that will help you understand what the numbers mean.